Hi and welcome back. So in the last chapter, I'd shown you how you can have a pipeline in place that can build .NET code, create an image, and then publish it onto the Azure Container Registry. Now, when building my pipeline, if I go back here, if I click on Edit, I did do some research on understanding how to create this pipeline. Because see, by default, if you look at the YAML file, the default YAML file, I told you that if you run it as it is, it's not going to work because it's going to take your source code and then put that source code into the image, which is wrong. It needs to take a build, and the build needs to go into your image. There is another way in which we can go about this entire process, and that is to make a change onto our Docker file, which I will show you later on. But there is something that I had to research on and try to understand that this is something that we had to do. We had to create tasks in our pipeline to first build our project and then take that build onto our image. That was the first thing. The next thing was trying to understand how to make this Docker task, because even if you have all of this code in place, right, to build your .NET project and then have the build in your artifact staging directory, even then, if you don't have this command of the build context, this Docker task will again still take your source code and not take the build in your artifact staging directory. Hence, I had to make use of the build context. But that's not enough. How did I come to know that I should go into the SQL app folder? And this is not magic, because I had to research on understanding that the files need to be taken from this directory. And the way I did that was to add another task actually here before the Docker task. Here what I'm doing is I've added a task. It's basically a PowerShell command that you can use within your YAML file. This will actually give an output in the log. So when you run the build pipeline, you'll actually get the output to tell me what are all of the files in the build artifact staging directory. Because initially, when I was trying to do a save and a run, this was during my research, I didn't put the SQL app directory. And obviously my image was not working as desired. And that's because the build files were going into a SQL app directory. But initially, I didn't know that. So in order to understand where the problem lies, I first want to understand, how does Azure DevOps? Because see, all this is happening on the Microsoft hosted agent. If this was our own self-hosted agent, I could log onto the machine and see the artifact staging directory in terms of how does it structure the files. But since the Microsoft hosted agent basically dies after the pipeline is complete, I need to find some way within the pipeline. It's like debugging. I'm trying to figure out how does Azure DevOps actually store the files. Hence, you could use many commands. So one command is a PowerShell command that you can embed within your YAML file. Again, this is just from a debugging purpose. Then later on, when you want to ensure that this YAML file is publishing your code for real in a production-based environment, you can go ahead and remove these commands. But I'm just saying that please go ahead and list the contents of this particular path. You can give any display name over here. Let me go ahead and do a save. And let's just wait once the build is complete. Once the job is complete, if I go on to the list content task, it's going to give me information about all of the files, basically, and the folders within that staging directory, which is there. If I scroll down, so this is basically all of my source code files, but I want to go on to my build files, and that's where it starts from. So it starts from here, and then we have our SQL app.dll, etc. And you can see everything is within a SQL app folder. That's when I came to know that I need to put that SQL app folder reference also when it comes onto the build context. And then finally, I came to know that the right image is being pushed, because if I go onto the build and the push stage, right, so this is all the logs. So logs are very, very important. It gives you kind of a headway on whether you are doing the entire pipeline process correctly. In terms of the size of my image, so this is the build ID, which is being tagged for my image. I think the size is 1788. It's actually the same size as the image which we had pushed earlier on manually. When it was not going as planned, it was taking the source code file, so the size was different. So at that point in time, I knew that something was wrong. It's not the right image. Once I got the size in place, okay, fine, I came to know, okay, we're on the right path. So, we are having the right files as part of the image. So in this chapter, I just want to give my experience. I want to share my experience on how I went about trying to build this pipeline when it came on to building my app and then pushing it onto the container registry. Hi and welcome back. Now in this chapter, I quickly want to show how we can create a release pipeline to deploy the image that we have within the Azure Container Registry onto an Azure Container instance. Here, let me create a new release pipeline. I'll start with an empty job. I'll say deployment to container instance. I'll click on save. Now this time our pipeline is a little bit different because I want to show as many examples as I can when it comes on to deployment and building when it comes onto your application. This time around, I'm not going to add an artifact because our artifact is already available as an image in an Azure Container Registry. So it's not required that you need to have an artifact in place. But then what you should know in this particular case is because you don't have an artifact in place, you don't have kind of a continuous integration cycle in place. Here you can do a manual release of this particular pipeline. Let me give a name. Here now, in terms of the job and the task, again, we need to have a task that will run on an agent. Let me add a task. Do I have anything when it comes on to container? Okay, we have a container build, we have Azure Web App for containers, Azure Functions for containers, we have Docker, Docker Compose, but we don't have anything when it comes onto an Azure Container instance. Now, when this is the case, if you don't have anything when it comes onto a task for deployment onto an Azure Container instance, what we can do is we can use other ways of deployment. One way I want to show you is executing Azure CLI. You can use the Azure command line interface to interact with your Azure resources and even Azure PowerShell. Coming from an AZ-104 background or even an AZ-204 background, you do know that you can use Azure CLI as a tool or even Azure PowerShell to work with your Azure-based resources. So we can just have a plain Azure CLI task for creating our container instance. Let me add the Azure CLI task. I'll go onto it. Let me go and choose my subscription. In terms of the script, I'll choose a batch script here. I'll scroll down. I'll choose an inline script and let me paste my script here. we are using the AZ container create command to create a new container within this resource group. We are giving a unique name for our container instance, so make sure you change the instance name here. We are giving amount of CPU and memory onto this container instance. We are saying to make sure port 80 is open. Please assign a public IP address onto this container instance, because if you don't mention this, it will be a private IP address, and we have to give what is the name of our registry. So I need to take this, copy it here, and in terms of the username as well, we'll copy it here. And what is our registry password? Well, let's go over onto our registry, onto the access keys. Let's copy the password, place it here. With all of this in place, let me go ahead and hit on save. And I told you we don't have any sort of trigger now for this. Let's create a normal release to see if it works. See, I'm trying to give you different ideas on how you can have these different tasks in place within your release pipeline. So I just took this as an example, wherein we could deploy an Azure container instance now. So we're actually creating a resource within our release pipeline. And this container instance should be taking the latest image. We had mentioned that also in our Azure CLI command from the container registry. Once this is complete, if I go onto all resources, I can see my container instance in place. Let me go onto it. I'll take the public IP address, go onto a new tab, and I can see my application in place. Very simple example on how you can add Azure CLI. You can also have PowerShell in place that can be added onto your release pipeline in case if you don't have the task in place to carry out the task that you want. Hi and welcome back. Now, let's extend the deployment of our image has containers onto Azure Kubernetes. We'll see how to use pipelines now to deploy containers onto the Azure Kubernetes service. For this, I first need to create an Azure Kubernetes cluster. In all resources, I'll hit on create. I'll search for the service. Hit on create. I'll choose my existing resource group. In terms of the configuration, I'll choose dev and test. I'll scroll down. Just give a simple cluster name. In North Europe, no available zones. Here, in terms of the size, I'll just change the size onto 2 CPUs. That's DS, or that's D2S_V3. Hit on select. I don't need scaling in place. I'll choose manual. I'll choose the minimum number of nodes since this is just a demo. Go onto node pools, onto access, onto networking. In integrations, since we already have a registry in place, I'll choose that Azure Container Registry. Go on advanced, tags, review, and create. And let's go ahead and create this cluster. This might take around 5 minutes. Let's come back once we have the cluster in place. Now, while the cluster is being deployed, we are going to deploy a container based on the image that we have in our Azure Container Registry. And for this, we are going to be using deployment manifest file and a service manifest file. We have again already seen this when it comes onto AZ204 and even AZ104. Here, I want to deploy my SQL app Docker has a container onto Azure Kubernetes. If you're following along, you can give any application name, just giving a simple name here. I need to change what is the image, basically my container registry name. So in another tab, let me make sure I take the correct name. Just filter on registry. Copy this. Let me place it here. Save it. And in service.yaml, I'm just creating a service of the type load balancer so that we can access our application from the outside world. Now, let's come back once we have our cluster in place. Now, once the cluster is deployed, if I go onto the resource, let me first manually show you how would you deploy your manifest files. It's very simple. If I go onto workloads, I can create a new workload with YAML. I can go onto my YAML file, copy all of this, place it here, click on add. Then I can go onto my services, again create with YAML, go onto the service, copy all of this, place it here, click on add. If I go onto my workloads, I can see my app is getting ready. If you click on refresh, you can see it is in the ready state. I'm going onto services. I need to ensure that for my service, there is now an external IP address in place. I can click on this. It will open the link in a new tab, the IP address. This should now be having, again, our same application connecting onto our Azure SQL database. So I'm having my Azure SQL database always in place when it comes onto all the labs where I have my application connecting onto the database itself. It's taking time to load because the container is still getting up and running and being attached onto the service. If you refresh the page, you can see your application again in place. Now, I'm going to delete my service and delete the workload because we're going to deploy both of this now via the use of our YAML pipeline. So let's move on to the next chapter. Now, in the last chapter, I'd shown you the manual deployment of our application via these manifest files onto the cluster. In this chapter, let's see how we can extend the pipeline that we have, our YAML pipeline. I'll just click on edit. This was the one which we had for pushing our image onto the container registry. Let's extend this pipeline itself to now publish, which we can do, our image as a container onto Azure Kubernetes by the use of our manifest files. I'll just delete this task that I have. Now, let me go onto a new tab. Go on to project settings. The first thing I'll do is to create a service connection. We need to create a service connection onto our existing Kubernetes cluster. Here I'll choose Kubernetes. I'll scroll down, go on to next. I'm connecting onto my Azure subscription. It will give me a dialog box to authenticate. Here then I'll choose my cluster. Now if you can't see your cluster in place, just go ahead and log out of your Azure DevOps account and then log back in again. In terms of the namespace, I'll choose the default namespace. I'll just give a name for the service connection. Grant access on all pipelines and click on save. Once I have this in place, now as part of my code base, which is being used to basically build my image, I'm going to put the manifest files here itself. In the project, I'll right click and add a new folder. I'll name this as manifest. Then let me add an existing item. I'll just browse onto the place where I have those manifest files. So it's in another folder. I'll add both of these files. Let me now check this into Azure repos. Let me do a commit all and a push. Definitely it allows me to first pull the changes. So I'll do a pull and a push. And it should trigger a build. For now, let me go ahead and cancel the build because I don't need that build to run right now. So let's go on to the pipelines. I can see the build hasn't triggered. Let me go on to the build and cancel the build process because I want to complete my pipeline. I want to now add a task. This is for Azure Kubernetes. So deploy onto Kubernetes. I'll choose that service connection. In terms of the manifest file, I'll just put as app.yaml for now. Let me click on add. Again, indentation is very, very important. Here, the only thing I need to change now is the location of both my app.yaml file and my service.yaml file. If I go on to another tab, let's go on to repos. In my SQL app Docker, here in manifest, I have my app.yaml file and service.yaml. This is now in my build.sources directory under the SQL app folder, under the manifest folder. Hence, I'm mentioning the same here as well. /SQL app /manifest. Is it manifest? Yes, it's manifest. So let's make sure to change it accordingly. And app.yaml and service.yaml. App.yaml, service.yaml. Right, so this all seems fine. Let me click on save. Deployment to Kubernetes. Let's commit onto the main branch. And let's wait till the build is complete. Now, once the job is complete, if I go onto my cluster, if I go onto workloads, I can see my app workload in place. If I go onto services, I can see my app service also in place. Let me open up the external IP address and I can see my application also in place. So now we have successfully extended our YAML pipeline so that it makes a deployment now a release onto Azure Kubernetes. So here I'm showing you how you can use YAML also to perform a deployment of your applications. Now, in the prior chapter, we had seen how we could deploy our application as a workload and a service via the use of the YAML pipeline. In this chapter, I want to show you how you can use a classic release pipeline to do the same. Firstly, I'll go onto my cluster. Let me delete the service and delete the workload also. I'll go onto my build pipeline, click on edit. I'll scroll down. I'll delete the task for the manifest because we'll do it via the use of release pipeline. Here, I'm just adding a task to publish my pipeline artifacts so that it is available in the release pipeline. Why do I want to do this is I want to ensure that the manifest file that we have, the app.yaml and the service.yaml is available as part of the release pipeline. I told you that when it comes onto this build pipeline, the agent that's going to contain our source files is going to be destroyed, but I want those YAML files to be available onto the next stage, that's onto our release pipeline. Hence, for this, I'm having a publish pipeline artifact task in place to go ahead and take those files and to make it available as part of my release pipeline. Let me click on save. I'll say added published pipeline artifact task. Click on save. This should go ahead and do a build. In another tab, let me create a new release pipeline. So go on to releases. I'll create a new release pipeline. Start with an empty job. Deployment to Kubernetes. Click on save. Close this. We give a name. Here, in terms of the task, I'll go on to the agent job. I'll add a task. Let me search for Kubernetes. I'll choose deploy to Kubernetes and click on add. We're going to have two tasks. One is for the app.yaml deployment. I'll choose my service connection. It's in the default namespace. When it comes onto the manifest file now, let me just wait for this to complete the build pipeline. It should then publish the artifact, which I can see here. If you go onto the artifact that is produced as part of the build pipeline, I'll click on this. We have our source files because we have given the name. If you go onto the S directory, which contains all of the source files, we have our manifest folder in place where we have our app.yaml and our service.yaml. I'll now click on this browse manifest. Here it's saying there are no artifact sources that are linked. So the reason for this is, let me go onto my pipeline. Let me add an artifact. In terms of the build artifact, I'll choose SQL app Docker. Click on add. Go back onto the task. Let's browse again. And we can see our source files now. Onto SQL app, manifest, app.yaml. I'll click on OK. Now let me go back onto my agent. Let me add a task. Again, deploy to Kubernetes. Click on add. This time I'll say service.yaml deployment. I'll scroll down, choose my connection in the manifest. This time we'll choose the service.yaml file. I'll click on OK. Once you have this in place, let me go ahead and create a release. Let's come back once the release is complete. Once the deployment is complete, if I go onto my cluster, let me refresh the workloads. I can see my workload in place. If I go onto my services, I can see my app service in place. If I open up the link, I can see my application also in place. So in this chapter, I want to show you how you can use your release pipeline to also deploy your manifest file onto the cluster. Hi and welcome back. Now in the chapter, I just want to give a quick note. This is based on one of the YAML files we had defined earlier on. Here I am in my SQL app Docker registry. If I go onto my Azure pipelines.yaml, if I go onto the history, since your YAML file is now part of this repository, you can look at all of the previous changes that were made onto this YAML file. That's the benefit of having your build YAML file as part of your code repository. If I go on to one of the earlier commits which we had done, so it will show a side-by-side comparison when it comes on to that particular commit we had made. If I do a modify content, if I scroll down, so we had this task of publishing a pipeline artifact. Since we wanted our source files, so we wanted our YAML files available as a published artifact so that we could use it later on in, let's say, a release pipeline. At that point in time, I was actually publishing all of the source files from our build onto the release. Now, you might be thinking, we only wanted particular YAML files or particular files to be copied across the pipeline. I mean, we don't want all of the source files. It's like a headache, right? You're copying all files which are maybe not required from one part, like from the build pipeline onto the release pipeline. I only want a certain set of files to be published onto the release pipeline so that they can be used. Well, you can do this. And we're going to be looking at an example on selectively taking files as published artifacts so that it can be reused later on. We'll do this in the next section when we're looking at building our infrastructure. At that point in time, I'm going to show you an example on how we can just take select files as a published artifact so that it can go in the next stage or the next part of our pipeline. I want to give this quick note if students are thinking, why Alan did you take all of the source files? So, say I want to go step by step. I want to first show you all that you all can publish your artifacts in your pipeline so that they can be reused later on. But then I'll also show you a selective way in which you can just choose certain artifacts to be carried forward in your pipeline itself. Hi and welcome back. Now, in the chapter, I want to go through a different way in which you can build your Docker image. Earlier on, so if I go onto the Docker file, all we were doing is we were creating an image based on our build. And in our pipeline, we were ensuring that a build was first conducted for our project, and then that build was placed into the image. I'm going to replace now this entire Docker file with a different Docker file content. So I've pasted the code here. What we are doing is we are having a multi-stage build, wherein the first set of statements is now going to restore our project and do a publish. So the build and the publish is being done here itself with the help of the Docker file. And then finally, we are creating a final image from the build that occurred in these set of steps. So we're doing the build and the publish here itself. Let me go ahead and save this. Since we have made a change onto our Docker file, go on to Git changes, Docker file, do a commit all and a push, do a pull and a push, because there were some changes made when it came onto Azure pipelines.yaml. Again, this should trigger a build. I don't want the build to be in place, so let's go on to our pipelines, go on to the build, and let's cancel it. Okay. Now, let me go back onto our YAML. Let me click on edit. So last time around, where did we leave off from? So we were having this publish pipeline artifact. So we can still keep this in place. If I go onto my cluster, let me delete my service. And let me go onto the workloads and delete the workload as well. Okay, coming back here. So all of these tasks now, it's fine when we are building and pushing an image onto the container registry and the publish pipeline artifact. But now since we are doing the building and publishing of our code base with the help of the Docker file, we don't need now all of the tasks when it comes onto the build and the publish. We don't even need the task of installing .NET. So I'm going to delete all of these tasks. And we're kind of coming back onto the original YAML file that got generated, wherein it was doing a simple build and a push. So probably this YAML default was assuming that as part of the Docker file, we had the build and the publish in place, or we just had the publish content as part of our repository. We can keep everything else as the same. Here in terms of the build context also now, I don't need to mention the artifact directory. Now we can keep this as it is. If I just go on to another tab, let me go on to repositories, just to check our Docker file. Right, it has the latest content. Let's do a save. So I'll put this as multi-stage Docker build. Click on save. This should trigger a build. Let's wait till this is complete. Now once the build is complete, if I go on to my releases, so I think one thing that I forgot to do when it came on to our Kubernetes deployment, let me click on edit. I forgot to enable continuous deployment trigger. Nevertheless, let's go ahead and create a release. I want to ensure that this new way that we have employed when it comes on to first, building everything within our Docker file and just doing a simple build and a push also works. Once it's complete, let's confirm. Let me refresh my workload. It's fine. Go on to services. It's fine. Let's open the external IP address. And we have our application in place. So in this chapter, I want to show you how you can have that multi-stage Docker file in place and then do a simplified version maybe of your YAML file when it comes on to building and pushing an image onto the Azure Container Registry. Hi and welcome back. Now in this chapter, I want to go through container jobs. Now up to this point, when we were looking at building our application, so let's take the case of us building our applications on a Microsoft hosted agent or even on a self-hosted agent. Now a build runs inside a compute instance, and for us we'd only be running one build at a time. Now if you're taking the case of, let's say, a self-hosted agent, you might be reusing that same infrastructure for having multiple builds of maybe multiple applications in place. You might be having the required tools that need to be installed. So I said you might be having different applications that would be building on the same machine. If this is the case, there could be a scenario wherein, because you need to install so many tools, so many maybe packages on that same machine to help the building of the different applications, there might be a conflict. So you might want to isolate the build process of each application. In this case, what you can do is you can make use of container jobs. So here you are using the concept of running everything within a container. Now, don't confuse this with what we've done earlier on. Earlier on, we were running an application as a container within the image. Here, Azure DevOps is providing you the functionality of running your build within a container. And I said, why would they want to do this? So I said, let's say you have a self-hosted agent in place. You have builds of multiple applications running on the same machine. So maybe you want to save on cost. You don't have multiple self-hosted agents. Now, each application, when it comes onto the build, they might be requiring different tools or packages to be installed. And I told you, in case if there is a conflict that's happening between these packages, because you might be having different package versions that need to be installed for each application, you want to isolate the entire build process on the same machine. Well, welcome to containers again, because with the use of containers, you can have that isolated environment. So now your build can actually run within containers on the machine itself. And I said, don't confuse this with having your .NET application running as containers. No. Here it is your entire job that's running within a container that's managed by Azure DevOps. You can just have a normal application running on that container job. So in the next chapter, let's look at an example on how we can accomplish this. So now in this chapter, I want to show you how you can make use of container jobs. Now what I've done is, for the Docker file, which I have as part of my SQL app Docker repository, I did an edit and I put the basic steps for just putting our published files as part of the image that gets created. This actually spun up a build. I canceled that build. I'm now going on to the SQL app Docker pipeline. I'm going to make changes onto the existing YAML file that we have. So I pasted the changes. Now, one of the major changes I'm doing is I'm now having actually multiple stages within my YAML file. We had seen having multiple stages within the release pipeline in the user interface, but now within the YAML definition itself, I'm creating multiple stages. Under stages, I have one build stage here, and if I scroll down, I have a deployment stage. What am I doing within this build stage? Well, I want to now build my project because I don't have it as part of the Docker file. I want to do a build and a publish. I'm doing now this build and a publish within a container within my VM image. So if you want to run steps within a container, you have to give what is the name of the base container that you want. So now these tasks which I have here, this build task and this publish task, it's going to run within this container. And how do we know it's running within this container? If it had to run within my Ubuntu latest VM as it is without the container, remember we need to add a task for installing .NET 6, but we are not doing it here. And that's because everything is running within this container that already has the .NET 6 SDK in place. So all we need to do is to do a build and a publish. Next, since we have multiple stages in place, I want to publish that artifact staging directory as an output onto the next stage. We can now publish it onto our pipeline. We were using a task earlier on known as publish artifacts. Actually, this publish is just a short form of that particular task. It's the same task. It's going to make the build artifacts available as part of the pipeline. The name we are giving, again, for the publish artifact is here, build artifacts. This artifact is nothing but the artifact name you are giving. So to make everything available across your pipeline, make sure that you publish the artifacts that need to be passed on. And here we want to publish or make the artifact run as part of the next stage. Now, in the deployment stage, which is my Docker build, I first need to have the very important step of downloading that build artifact into the stage so that it can be used. When I was actually trying to develop this YAML file, this was the problem I had when I was not downloading the build artifact. So again, this took research on trying to understand how do I build this end to end. And please note that the steps in this particular stage are not running within the container. It's only running within the VM itself. So as part of different stages, we can tell where it should run. These tasks within the build stage are running within my container on the virtual machine, whereas these steps are running within the VM itself, right? Our Ubuntu latest image here, we're not specifying any container. If I had to run the Docker task within this container, it would not run because this container by itself does not have the capabilities of running a Docker task. This only has the capabilities of having the .NET 6 SDK in place, which you can use for building and publishing your application. So try to keep all of this in mind, as you're building your pipelines. Where or what should you use for running the pipelines itself? So in this Docker task, which is just running on the VM image itself, I have all of the similar aspects. So now next, if you want to reference that build artifacts when it comes onto your SQL app, this time the inbuilt variable you need to use when it comes on to accessing those artifacts as part of your pipeline is pipeline.workspace. This is the inbuilt variable that you're going to use. So actually, just to make things a little bit simpler for now, let's remove the final step when it comes on to the publishing of, onto the pipeline when it comes onto Azure Kubernetes. For now, let's see how this works. Just has multiple stages within this YAML kind of build file. So let me go ahead and click on save. I'll say using container jobs, and let me click on save. Now, if you go on to using the container jobs, you can see multiple stages now in place. It's first going on to the build stage. Here, when you look at the visual representation, you have two stages in place, and within the stage, it's going ahead and now executing the job. We have one job, that is the build job within the build stage that has all of these tasks. And then within the deploy stage, we'll have another job which will have its own task. Let's wait till this is complete. So the build stage is complete. It should now start with the deploy stage. So it's going ahead with the deployment stage. And once the entire build is complete, what I quickly did is I spun up a new instance based on the latest version of the image which is available in that container registry that is based on our build. And I just confirmed that I have the application in the running state. So in this chapter, I want to show you how you can make use of container jobs now when it comes onto your pipeline. Now, just as an added step from our previous build, what I've done is, as part of my task, I was able to access the app and service.yaml file as part of the variable build.sources directory by adding the manifest Kubernetes task here. I then ran the pipeline, and I confirmed that I have my application, and I also have my services available. So we go on to my service. I can see it has an external IP address, and it works as expected. So now, as part of the pipelines, I do a lot of experimentation when it comes on to making artifacts available that may not be available as part of your pipeline in subsequent stages. But since I could still access my sources directory in terms of the build, I went ahead and added this task of using the manifest file after the image is published onto the Azure Container Registry. So now once all of this is complete, I'm going to go ahead and delete the resources that are no longer required. Let me go on to my resource groups. I'll go on to Docker GRP. This has my cluster and has my registry. I'll delete this resource group because it is no longer required. I'll go on to my other resource group, that's DevOps GRP. Also, I don't need now anything because we are going to be moving on to the next section wherein we are going to be building our infrastructure via the use of code. Even here, in order to save on cost, I can choose to delete the resource group. Actually, just ensuring that I don't bear any additional cost when it comes onto my resources itself. Now, in this chapter, I just want to give a quick note when it comes on to technical debt. Now, initially, when you develop your application, you might be taking all of the right measures in place to ensure that you have quality in place for development of the application. But then, after it is promoted to production, when you start adding features, at that point in time, because of time constraints, because of budget constraints, developers may not have enough time to incorporate quality when it comes on to coding these additional features. Now, because of this, you could be having code that may not be structured in a particular way, might not be following the right standards. And then over time, when developers want to start making more and more changes onto the application, it could start becoming difficult to make these changes. And this could be because of the quality of code that was put in place as part of the previous application changes. It's not up to the mark. Because obviously, over time, if you don't look after the quality of your code, the maintainability of the code becomes difficult. This can actually be tracked by the Sonar Cloud tool. Here, when it comes on to maintainability, it also keeps a track of the technical debt. It has something known as code smells, wherein it looks at code that is confusing and difficult to maintain. It can give you these sort of attributes. So something that you should also consider, wherein using the code quality tool to ensure that the technical debt does not increase for your overall code base. You want to kind of give this important note when it comes on to code quality. Now, in this chapter, I just want to give a note when it comes on to the deployment settings for your pipeline. Here for an existing pipeline, if I click on Edit Pipeline, here let's say, for example, I go on to the pre-deployment conditions. We have seen how we can have approvals in place, how we can have gates in place. There is something also known as deployment queue settings. See, sometimes you might have multiple builds triggered for your application at a time, or you could have another build that is taking time to complete, and during the time, another build is triggered. When you have multiple builds that are coming onto your release pipeline, you can first of all decide what are the maximum number of parallel deployments you want to have in place if you want to really deploy all of the builds one by one. Or you might just have the requirement like, discard the old build, just take what is the most latest one and deploy it onto the pipeline and cancel all of the other builds. This is something that you can actually control via the deployment queue settings. I just want to kind of give this note when it comes onto release pipelines. Now, in the prior chapters, we had seen via the use of release pipelines, how we could deploy our application on, let's say, a set of Azure virtual machines, or maybe an Azure web app. At that point in time, we had ensured that we had those resources already available as part of our Azure account. But obviously, during the entire process of automation, especially when it comes on to deploying application on a test infrastructure, you might normally want to have the creation of those resources, such as the Azure Virtual Machine, the Azure Web App, etc., part of the entire pipeline process. You might not have the resources running beforehand because you might want to save on cost. Because if you have running resources, such as Azure Virtual Machines, Azure Web Apps, or your Azure SQL Database, and you have nothing running on them, then it's just a waste of compute resources. And there's a cost associated with having those compute resources in place. So as part of your resource pipeline, you might want to ensure that you also put the building of your infrastructure in place. When it comes onto your production-based environment, you will always have the resources in place. You will just have the deployment of your application and the updates for your application onto that infrastructure. This is normally when you're building and deploying applications on, let's say, your test infrastructure. So I told you when it comes onto your application, you could have a very simple infrastructure wherein you could have the application, if it's a web application, deployed on Azure Virtual Machine, which is behaving as a web server. And let's say you have a database engine running on another Azure Virtual Machine. Or you may decide to use Platform as a service wherein you deploy the application on an Azure Web App and it connects onto an Azure SQL database. So all this when it comes onto infrastructure, there are some things that you have to consider. Obviously, the first aspect is creating your infrastructure. At points in time, you might need to make changes onto the infrastructure itself. So yes, you might have changes to your application based on new features or updates, but at the same time, you might need changes even onto your infrastructure as well. For example, if you're deploying an application on Azure Virtual Machine, maybe you need to change the size of the VM to incorporate more load when it comes onto your application or other such infrastructure changes. Also, another important aspect is replicating the same infrastructure changes across multiple environments. So when it comes on to large organizations, when they're working with a critical application or managing a critical application, they might be having a development environment in place, a test environment in place, a staging environment in place, and then production. So for development, test, and staging, they would have separate infrastructures in place, and they would want to, at least at some point in time, replicate a similar type of infrastructure across these multiple environments. And sometimes when it comes on to building your infrastructure, you might not document properly how did you actually build the infrastructure in the first place. See here, I'm just looking at a very simple example where you might have an Azure Web App and an Azure SQL Database. When it comes onto a complex application that has many interfaces onto other components, this could get very complex in nature when it comes onto defining your infrastructure. You might have a lot of infrastructure components in place. So at that point in time, you might consider the aspect which is available of developing and deploying your infrastructure as code. See, when we were deploying our Azure Web App or our Azure SQL Database or the Azure Virtual Machine, we were going onto the Azure portal and building those resources. But obviously, you can also define your infrastructure as code as well. This is a facility that is available. By having your infrastructure as code, it helps you clearly define how the infrastructure should look like. You can also make changes onto your infrastructure easily with the help of just changes onto the code file. You can also version control the code file that is used to define your infrastructure. And then you can also replicate your infrastructure across multiple environments. So if you have, let's say, a development, staging, and a production environment, you can probably use the same infrastructure code file to define the infrastructure across all of these environments. If you're coming from an AZ204 background or an AZ14 background, you'll already be familiar with infrastructure as code. And you might have heard of some of the tools that are actually available when it comes on to defining your infrastructure as code. For example, when it comes on to Azure, they have tools such as ARM templates that you can build, and the newer version known as Bicep, when you can actually declare code or define code that can be used to deploy resources on the Azure platform. Another popular tool is also Terraform that helps you to basically define infrastructure as code. And remember that you also have tools that can be used for creating scripts such as Azure CLI and Azure PowerShell modules that also give you the capabilities of deploying your resources via the use of scripts. Now, obviously, we're not going to go into in-depth detail when it comes on to usage of these tools. I'm going to show you examples first, just as quick revision on how we can use ARM templates first to deploy an Azure Web App, an Azure SQL Database, and Azure Virtual Machine, just as a recap, because you probably learned about ARM templates when doing either AZ104 or AZ204. The reason I'm showing the ARM templates for an Azure Web App and Azure SQL Database is because in the prior chapters, we had actually looked at our pipelines on deploying an application onto an Azure Web App and a database and a table and data within the tables in the prior section itself. I want to now go ahead and simulate the deployment of the infrastructure. So in the earlier chapters, we had manually built our infrastructure. Now I want to build our infrastructure via the use of these tools. We're going to look at how we build this infrastructure via the use of ARM templates, via the use of Terraform, and also via the use of Azure CLI, just as examples, so that you get a better idea on how we can use infrastructure as code or even scripts for building our infrastructure. Obviously, it is impossible to go ahead and cover all of the topics when it comes on to ARM templates or even Bicep or even Terraform. In fact, I have a complete course on just Terraform itself when it comes on to working with Azure modules, because there's a lot that you can actually do when it comes on to a tool which does infrastructure as code. Here, the primary purpose when it comes on to AZ400 is to understand how do you incorporate the use of such tools within your pipelines, and that is what we are going to do. Now, the first thing we're going to look at is the usage of ARM templates within our pipeline. First, I'll do a revision when it comes on to building ARM templates. We'll look at an example of an Azure Web App, an Azure SQL Database, and Azure Virtual Machines. And then we'll see how to incorporate the usage of ARM templates for an Azure Web App and Azure SQL Database when it comes on to our pipelines. Second, you can go ahead and use ARM templates to define your infrastructure as code. You create something known as an ARM template or an Azure Resource Multi-Template. This is actually a JavaScript object notation file that actually contains the definition of your infrastructure. You can then store your ARM template in your source code repository along with your application code. Microsoft has also released a new language called Bicep that has the same capabilities of ARM template. Bicep just uses a syntax that's actually easier to use. We are going to be focusing on the usage of ARM templates. If you go on to the documentation page, when it comes on to the structure of the ARM template, here you have the basic parts of an Azure Resource Multi-Template. Within the resources block, you'll actually define the resources that need to be created. You also have parameters which allow you to dynamically send out values onto your template. I'm going to be using Visual Studio Code as my editor for building ARM templates. In Visual Studio Code, you can actually install an extension. I've already got that installed. That's Azure Resource Manager Tools. This allows you to quickly create ARM templates within Visual Studio Code. So again, if you don't have this editor in place, Visual Studio Code is a free download. Just to kind of help in building our ARM templates, I'm making use of Visual Studio Code. You can go ahead and install the extension of Azure Resource Manager Tools. Now let's move on to the next chapter, wherein we'll build our ARM template when it comes onto an Azure web app. So now in this chapter, we will look at how do we deploy an Azure web app via the use of an ARM template. Now, when it comes on to the deployment of an Azure web app, you actually need two resources to be in place. One is the web app itself, and the other is the app service plan. You know that an Azure web app needs to be part of an app service plan. Hence, in our ARM template, we're going to have the deployment of two resources. One is the Azure web app, and the other is the app service plan. When it comes on to the structure for the ARM template, you should refer onto the Microsoft documentation. Now, when it comes on to the resource type for an app service plan, it's actually Microsoft.web server forms. And in another page, I have the type for the Azure web app itself. That's Microsoft.websites. I've gone on to the deployment reference page. This is when it comes on to ARM templates for both of these resource types. Here, when it comes on to understanding what is the deployment language you're choosing, so I've chosen ARM template. When you choose this and when you scroll down, it will have the entire resource format when it comes onto an ARM template. If you choose Terraform, it will show you what is the resource format when it comes onto Terraform itself. When you come onto the ARM template, one very important note is the API version. Currently, I'm using the current API version. Depending upon the API version you choose, there might be a slight change when it comes onto the resource format, which is used for the deployment of the resource. If you look at the resource format for either of these resource types, so there's a lot that comes onto what you can define as part of the resource. As you know that when you deploy an Azure web app, there are so many things that you can actually configure for an Azure web app itself. And the entire idea is you should be able to deploy all of the features as part of the Azure web app when you are deploying an ARM template. That's why you have all of these features that can be defined as an ARM template. We're going to make ours very, very simple. We don't want to complicate the definition when it comes onto our Azure web app or our app service plan. I'm going to go on to my first resource type, that is for server forms. This is for the deployment of an app service plan. I'm going to scroll down. So we have the definition in place when it comes on to the app service plan. I'm going to go on to Visual Studio. I just opened an empty folder on my C drive. It's a template folder. I don't have anything within the folder. So I went on to File. I clicked on Open Folder and it shows an empty folder within my C drive. You can do the same thing. If you can't create a folder on your C drive, then open it on your D drive. I'll create a new file here. I'll choose New File. I'll just name this as template01.json. Now, if you install that ARM template extension from the marketplace, if you just type in ARM and do a tab on your keyboard, you will get the default structure when it comes onto your ARM template. Next, I'll define the resource I want to create. If you want, you can choose the type from here. But I'll go back onto the documentation. Let me take the first four, basically, attributes of what we want to define for this resource when it comes onto the app service plan. So we have the type, the API version, the name, and the location. In terms of the name, so let me give a unique name when it comes onto the Azure web app. Please ensure that you change the name accordingly. When it comes onto the resource, you can put the location of the resource in the Central US, East US, North Europe, depends upon the location for your resource. I'm going to use an inbuilt function that's available, wherein we can use what is the location of our resource group. So this function will automatically evaluate onto the location of the resource group in which this resource is deployed. I want to next define the SKU. So scroll down here, just define the SKU. In the SKU, we can specify a name of F1. This indicates that we want to use the free tier when it comes onto the app service plan. This should be fine by us. And we can provide something known as a capacity of just 1. And this should be good enough when it comes onto the deployment for the app service plan. Next is the deployment of the Azure web app itself. I'll go on to the next tab, which has the definition for the web app. Again, I'll take the type, the API version, the name, and the location. Let's place it here. Again, for the location, I'll do the same thing. I'll take the resource group here. In terms of the name of the web app, again, we have to give a unique name. I'm going to look at defining now the properties for this Azure web app. In terms of the properties, if I go onto the properties section here, there's something known as the server ID form, which is important. So let me copy this, place it here. The server ID form is actually the resource ID. So we have another function, inbuilt function, when it comes onto ARM template, that is a resource ID. See, since our Azure web app is going to be part of our app service plan, we have to link both of these resources together. In the resource ID, we have to give what is the resource type, and next, what is the resource name. In terms of the resource type, this is the resource type. I'll just copy it, place it here. And what is the name of the resource? That's the plan here. I'm also going to add something known as a depends on clause. Here we're just trying to say that this Azure web app has a dependency on the app service plan. So we should tell Azure, please ensure to first create the app service plan before you create this Azure web app. In the depends on, we can again mention what is the resource ID. So I can just copy this and place it here. Another thing that I'm going to do is when it comes onto my app service plan, I need to also define properties. So this will be after this queue. In terms of the properties, I just have to mention again what's going to be the name of our app service plan. This is fine. Similarly, here in the properties, let me define the name, and it's going to be the name of our Azure web app. Let me save this. Now you could deploy your ARM template. So let's copy all this. You could deploy your ARM template via the use of PowerShell. You can do it from Visual Studio Code itself, or you could also use Azure. Now in Azure, for deployment of these resources, I'm going to create a new resource group. So I'll go on to resource groups. Let me create a new resource group known as template GRP. I'll choose North Europe as my location. Go on to view and create. And let me go ahead and hit on create to have this resource group in place. I'll now hit on creating a resource. I'll choose template deployment, hit on create. Just hide this. I'll build my own template in the editor. I'll replace all this code with the code I have in Visual Studio Code itself. I'll click on save. I'll choose my new resource group. Yeah, it is taking out the location of my resource group. And since in our code in the location, we use the function of resource group, hence now both of our resources are going to be deployed in North Europe, which is the same location as our resource group. I'll go on review and create. And let me go ahead and hit on create. So now here we are deploying a code file which is telling Azure on what resources we need to be deployed as part of a resource group within our Azure subscription. Once this is complete, if I go on to the resource group, if I scroll down, currently I can only see the app service plan in place. Just take some time. You have to click on refresh. After waiting for a minute, let me click on refresh again, and I can see my web app also in place. So in this chapter, I want to get started with how do you develop an ARM template that can be used for deploying an Azure web app and an app service plan. Hi and welcome back. Now in the prior chapter, we have built an ARM template for the deployment of an Azure web app. In this chapter, let's look at an ARM template that can be used for the deployment of an Azure SQL database. Now when it comes again on to the deployment of an Azure SQL database, we need to have two resources in place. First is the deployment of the Azure SQL database server that is used for hosting the SQL database, and the next resource is the SQL database itself. When it comes on to the resource types, I'm going to be using Microsoft.SQL servers when it comes on to the Azure SQL database server. And the other one is the databases type itself for defining our Azure SQL database. Now again, when you want to understand what are the resource types for the different resources, what you can do is you can actually take a reference from the resource itself. If I go on to, let's say, the app service plan that we had deployed in the prior chapter, every resource has properties. If you go on to the properties, here if you scroll down, in terms of the resource ID, let me copy this onto the clipboard. I'll put a notepad. You will see the provider. That is basically the resource type for this particular resource. This will actually give you an idea on what is the type you should search for in the documentation. So what you can do is you can first manually deploy the resource, and then you can search for the resource type accordingly. Right, so going back, I said the first thing is to deploy our SQL server. In Visual Studio Code, I'll go ahead and close this. Let me create a new JSON-based file. This will be for the deployment now of our Azure SQL database resource. Again, I'll do an ARM and a tab. I can just go ahead and hide all of this. I want to define resources again. There will be two resources. One is for the SQL server and the other is for the database. Let's go back here. I'll take again the type, the API version, the name and the location. Let me place it here. So we have the API version. In terms of the name, let me give a unique name. And in terms of the location, we'll do the same thing. I'll take the resource group location. I'll just copy this. And let's place it here. Apart from this, I want to define the properties. In the properties, so if I go on to the documentation, we have the properties. I need to specify what is the administrator login and password. This actually helps us to log into the database server. I'll copy it and place it here. We can define our administrator login and the password to be taken as parameters. Hence, for our template, let me go ahead and define some parameters. Onto the parameters section, I'll define one for the SQL login. This is going to be of the type string. I'll just add some metadata where I can just put a description saying the administrator username, and I'll add one more parameter. This will be for the password. So this is a SQL password, the administrator password. So we'll accept these values at runtime. I can define this as a secure string because it's going to be a password that we're going to pass in. And then if I scroll down, I can replace this by taking it as a parameter or taking it from the parameter section. The name of my parameter is SQL login. I'll do the same thing here. Take it from the parameters, and this time I'll take the SQL password. And so we have this in place. This is one resource. The next resource we need is our SQL database. Again, here, let me take the type, the API version, and the location. Place it here. The API version, let me give a name for the database as AppDB, and for the location, okay, let's take it from the resource group. I'm going to find the SKU for the database, which is also available. In terms of the SKU, I'm going to be using the basic SKU that is available. This is the least cost option. Apart from the SKU, I need to mention properties as well, which is going to be empty, but this is still required to be defined. And then I'll add the depends on attribute. Since this Azure SQL database has a dependency on our SQL database server, choose resource ID. We need to specify what is the type and what is the name. I'll scroll on top. Let me take the type and let me take the name specified here. Now, when it comes onto the name of the database, in addition to providing just the name of the database itself, we also need to append it with our database server. The way we're going to do this is we're going to be using the format function that's available when it comes onto ARN template. So I'm specifying two placeholders here, 0 and 1. Place a comma here. 0 is going to be appended with the name of my SQL database server, and 1 is going to be appended with the name of my database. So I'll take my SQL server name and place it here. So this is important. This is how you'll actually format the name of the database itself. Once you have all of this in place, let me save this and let's copy this. I'll again create a new resource. Choose the template deployment. Hit on create. Build my own template in the editor. Replace all of this. Click on save. Choose my resource group. Here you can see we can mention what is the SQL login and password. And since we have put this as a secure string, it's taking it as a secure string when it comes onto the password. Go on review and create. So we are getting a validation error. Let me go back here. I just forgot the slash here. This is important in terms of the separation between the server name and the database name. I'll save this again. I can go back on to previous, edit the template and make the change here as well. Scroll down. Click on save again. Choose my resource group. Mention the login and the password. Let's go on to review and create again. And now it's fine. Let me go ahead and hit on create. And let's come back once the creation process is complete. Now, once the deployment is complete, if I go on to the resource group, so I should be seeing 4 resources in place. I have my SQL database, our previous app service plan, and our Azure Web App, and the SQL database server itself. So we now have all 4 resources part of this resource group. Now, in the next chapter, I'll just show you an ARM template for the deployment of an Azure virtual machine. Then in the subsequent chapters, so up till now, I've just been doing a revision on how we can deploy resources via an ARM template. In the later on chapters now, we'll take this example of an ARM template when it comes on to the deployment of an Azure Web App and an Azure SQL database and then put it in our pipeline. We now want to see, if we don't have these resources in place, how can we deploy now our resources via the use of ARM templates and via the use of pipelines. Currently, I'm just showing you the basic exercise of how do we deploy our resources via the use of ARM templates. Now in this chapter, I just want to do a quick revision when it comes on to the ARM template for an Azure virtual machine. And that's because there's a lot that's actually employed when it comes on to the deployment of an Azure VM. You remember that when coming from an AZ-104 and AZ-204 background, when you look at the deployment of an Azure virtual machine, there's a lot of aspects that you need to consider. First of all, the Azure virtual machine needs to be part of a virtual network. That means if you deploy this as a separate resource, within the virtual network, you'll have different subnets in place, subnet A and subnet B. You'll have a network interface that is going to be attached onto the virtual machine. You can have a public IP address that is attached onto the network interface. This is when it comes onto traffic from the internet coming into the Azure virtual machine. You can have an additional data disk that can be used for storing data on the Azure VM. You can have an Azure storage account that is used for boot diagnostics for the Azure virtual machine. And you can have a network security group that is, let's say, attached onto a subnet. I just quickly built an ARM template that has the deployment of all of these resources. So I just added that code here itself. It's template 03.json. In my resources here, I first have the deployment of my Azure virtual network. I'm giving the name of the network. In the properties, I'm mentioning what should be the address space when it comes onto this network itself. I'm then defining 2 subnets. Subnet A, which has its own address prefix. And here in the ID of the network security group, I'm saying please attach a network security group, which I'm creating later on, onto the subnet itself. I'm then declaring subnet B, which is going to be an empty subnet. I won't deploy anything in the subnet itself. We'll show you that you can have multiple subnets deployed as part of your Azure virtual network. Then I have the public IP address. This is going to be attached onto the network interface. I have the deployment of the network interface resource itself. In the IP configuration, I'm mentioning what is the public IP address that needs to be attached onto this network interface and what is the ID of the subnet. So this network interface needs to be launched in this particular subnet. And then I have the depends on clause as well. And then I have the deployment of an Azure storage account, which can be used for boot diagnostics for the Azure VM. I have the definition of a network security group in which I have one role to allow traffic on port 3389. And then I have the deployment of the Azure virtual machine itself. Here it has a dependency on the storage account. I'm specifying what should be the size of the Azure virtual machine, what should be the username and password to log into the machine. It's based on Windows Server 2019 data center. It has an OS disk. It has an additional data disk. And in the network profile, I'm attaching the network interface. And here for the storage UI, this is required for boot diagnostics. So it's a quick revision when it comes on to the ARM template for the deployment of an Azure virtual machine. Again, I can copy all of this. Here, let me go on to creating a new resource. I'll choose again template deployment. Hit on create. Build my own template in the editor. Replace all of this. Click on save. Choose my resource group. Go on review and create. And let me go ahead and hit on create. It'll take around 3 to 4 minutes. So if we're just doing a quick revision, we're actually going to be focusing more on how do we use the templates we had seen earlier on when it came on to the deployment of the Azure Web App and the Azure SQL database, because I'm going to be using those as examples when it comes on to our further chapters when it comes on to Azure pipelines. I see this as a quick revision when it comes on to the deployment of an Azure VM. I want to make sure that we have the capabilities of deploying in Azure VMware by the use of an ARM template. Once the deployment is complete, if I go onto Azure Virtual Machines, I can see my app VM in place. What I'm going to do now is I'm going to go onto my resource group that I have. I'll delete the resource group because I want to delete all of my resources. This first set of chapters was just as a revision when it comes onto ARM templates. We are going to look at further aspects when it comes onto ARM templates and then also look at how we can use it within Azure pipelines. So for the moment, I'm going to go ahead and delete this resource group so that all of the resources are deleted, and I'll recreate the resource group again so we have an empty resource group with no resources in place. So first I'll delete the resource group. The easiest way to go ahead and delete your resources. And once this is done, I'll go ahead and recreate the resource group again. Right, so this marks the end of this chapter. Now, before we can look at how to use ARM templates as part of Azure pipelines, I want to go through nested and linked ARM templates because it's part of the exam objectives. Now, in our case, when it came on to building the ARM template, it's quite simple. We don't have that many resources in place. But sometimes if your application architecture, your infrastructure is quite complex in nature, wherein you have a lot of resources that need to be deployed, it could sometimes become difficult from a maintainability perspective to put all of the resources within one template itself. You could consider actually breaking your template into multiple pieces, and you can do this with the help of either creating a nested or a linked template. In a nested template, you define the resources, the nested resources within the template itself. So I'll show you an example on this. Or another way is to define your resources within another template itself and then link it in the parent template. Now, by having linked templates, you can have the concept of modules in place wherein you could have some core resources that need to be deployed in multiple application environments. So you could define that in one template and then reference that template in multiple parent templates itself. Now, before we go on to nested and linked templates, just a quick note when it comes on to deployment modes. When you deploy a template, there are some deployment modes in place. You have the incremental mode. Here, the resources within the template are deployed. It does not interfere with other resources that are defined in the resource group, which are not defined in the template. See, in our case, we had one resource group, template GRP. We were then using a template, let's say, to deploy an Azure Web App and an Azure App Service Plan within that resource group. By default, this is not going to interfere with other resources within the resource group that are not defined in the template. So let's say we already had resources within that resource group. The incremental mode will ensure that it does not tamper or do anything with other resources within that resource group. Whereas, if you do the complete mode, here, only the resources defined within the template will be defined in the resource group. If there are other resources within the resource group that are not managed by the ARM template, they will be deleted. When it comes on to nested and linked templates, the only mode that is available is the incremental mode. Now let's go on to seeing examples when it comes on to nested and linked templates. Now, just as an example, when it comes on to nested templates, so it's like one template within another. First of all, let me create a new template file here. I want to now combine the deployment of my Azure Web App and my Azure SQL database within one template itself. As the main template, let's have it as the deployment of my Azure Web App. So I'll go on to 01.json. Let me copy all of this onto here. Just close this. This is for my deployment of the Azure Web App. So currently, in Azure, what I've done is I create a fresh new resource group, template GRP. Currently in this resource group, I don't have any resources in place. We have the definition when it comes on to our resources for the Azure Web App. After the deployment of the web app itself, let me add another resource block. This is going to be for the internal deployment of our Azure SQL database. I need to mention a type here. The type is going to be Microsoft.resources/deployments. I'm going to add an API version for this. I'll give a name for this template. So I'll call this as child template. In the properties, let me define some properties. The first thing we'll define is the mode. I told you this can only be an incremental mode when it comes on to nested or linked template deployments. And then next, I have the template itself. In this template block, let me go on to the template deployment, where I have the deployment of my Azure SQL database and the database server. I'll copy the schema and the content version. Let's place it here. And then after that, I can directly put my resources block. Let me scroll down, take my entire resources block. Let me place it here. So it's defined. So I have the resources block in place. What I'll do is, let me just make a change onto the server name. Just a quick change. And let me scroll on top. I need to also define my parameters. So I can take the parameters block. And we can place this in our main parent template itself. This is fine. So what we're doing here is we're just putting the definition of a nested resource, that is our Azure SQL database, within our main parent deployment resource itself. One more thing that I'll do, let me just hide this before I copy it. So we have the new server that we have defined here. Let me ensure that also in the depends on I make this change. Now let me copy all this. Onto Azure, let me create a new resource. We'll choose template deployment. Hit on create. Build my own template in the editor. Let me paste all of this. I'll click on save. I'll choose my resource group. Specify the SQL login and the password, go on review and create. So the validation has passed. Let me go ahead and hit on the create button. Now let's come back once the deployment is complete. So during the deployment itself, you can see we have the Azure Web App in place, we'll have the Azure App Service Plan also in place, and now it is going ahead and deploying the child template. And the child template has the definition when it comes onto our Azure SQL Database Server and the Azure SQL Database itself. And after some time, you'll see the deployment is complete. If you go onto the resource group, currently I can only see my App Service and the App Service Plan in place. After you refresh a minute or so, you should be able to see the Azure SQL Database as well. So after just waiting for a minute and clicking on the refresh button, I can see the SQL Database also in place. So all we've done here is we have deployed one template within another via the use of nested templates. So in the last chapter, we had looked at how we could deploy many resources via the use of a nested template. In this chapter, let's look at an example of using linked templates. So again, we'll go ahead with the deployment of our Azure Web App, the App Service Plan, and our Azure SQL Database. In my template GRP resource group, let me delete the resources because I'm going to recreate them again via the use of a link template. In Visual Studio Code, let me create a new folder. And within this folder, let me create a main.json file. This will be like our parent template in which we'll be having our primary resources. In this, let us take the example of having the deployment of our Azure Web App in place in this primary template. I'll again do an ARM and a tab to have the default template structure in place. Let me copy the resources tab for deploying my App Service Plan and the Web App. So I'll place it in the resources section. This does not change. Let me now create within this link templates folder another JSON file. This will be for the deployment of our SQL database. And let me copy the template we had seen earlier on when it came on to the deployment of the Azure SQL Server and the SQL database. This is like a separate template on its own. I'll copy all of this and let me place it in the SQL database.json file. So we have the parameters in place and we have our resources in place. Here, let me just quickly change the SQL Server onto a different value. One of the reasons why I am changing the SQL Server name is sometimes I do face a problem when I try to deploy the same Azure SQL Server again. If I probably do this after some time, then I can probably recreate that SQL Server. But immediately after deleting the Azure SQL Server, and if I try to recreate it again with the same name, I normally run into an issue wherein it does not get created. It actually takes forever to go ahead with the creation of that Azure SQL Database Server. And since I'm doing this very frequently, that's why I go ahead and just change the server name. So this is my experience when I'm trying to create the SQL Server by the use of the ARM template. You may not face a similar issue, but since I want to go ahead with the creation of the resources, that's why I'm just making a small modification when it comes onto the server name itself. So let's make sure to save the file. Now in my main.json file, I want to link this SQL database.json file as a linked template. Again here, if I scroll down, this is after the resource deployment for the Azure Web App. It's like we are creating again another resource block. The type is again going to be Microsoft.resources/deployments. I'll give an API version. I'll give a name. I'll mention the properties. In terms of the properties, again the mode is going to be incremental. And then I need to mention something known as the template link. Where is my template located? For the purpose of the template link, I'm actually going to upload my SQL database.json file onto an Azure storage account because here we need to mention a URI when it comes onto the template itself. So we need to have some place where we have the template uploaded already. For this, I'm going to make use of an Azure storage account. Hence, in my template GRP resource group, I'm going to create a new resource. I can search for storage account. So I'll choose the storage account service. And we can always go ahead and create a new resource from here as well. I'll choose create. I'll choose that resource group. I'll just give a unique name for the storage account. I'll choose the location as well. Scroll down. Choose locally redundant storage because I don't need redundancy for now. Let me go directly on review and create. Let me hit on create. Let's come back once you have the storage account in place. Once you have the storage account in place, I'll go on to resource. I'm going to choose containers and let me create a new container. I'll name this as templates. Just for now, I'm going to choose the public access level as blob anonymous access and hit on create. So if we have anonymous access onto the blobs that we store within this container, I'll go onto the templates container. I'm going to upload that SQL database.json file from my local system. Once I have this in place, I'll go onto the file. I'll copy the URL and then I'll place it here in the template link. I need to mention a property of the URI and then here I can mention that entire link. So basically it's my storage account .blob.co.windows.net /templates, the name of my container and the name of my JSON file, basically my template. I also need to mention what is the content version. So I'll mention that accordingly. Here now, if I copy the entire content when it comes onto main.json and let me place it here, let me click on save. I'll choose my resource group, my region. I'll go on to review and create. So it's doing a final validation. Now in the validation, I'm getting an error because it's saying the value for the template parameter SQL login is not provided. Remember for our SQL database.json file, so I've opened the file up. Remember it's within our templates container, our SQL database.json file. We have two parameters that we need to specify values for, the SQL login and the SQL password. when we were doing our deployment on the previous screen, it was not giving us the chance to actually mention the values for those parameters. Now we have kind of a link template. So our main template is actually referencing a link template. So how can we specify the values for those parameters? Well, there are a couple of ways we can go about doing this. The way we're going to do this is we're going to create another JSON file in our links template folder. This is going to be for our SQL database parameters. You can always also have a generic parameters file. Here I'm going to paste in the code for the values of those parameters. So I have a schema, the content version, parameters, and what are the names of the parameters and what are their values. I'll go ahead and save this. Let me upload this also onto my container. So go onto the templates container, click on upload. I'll upload that SQL database parameters JSON file, hit on upload here. If I go onto my main template file now here, apart from mentioning what is the template link, I can also mention something known as the parameters link. Hence, if you have your parameters, the values for those parameters defined somewhere else, you can specify again the URI. And I need to mention also the content version again. So I'll copy this, place it here. What is the URI? Again, pretty simple. Go onto the parameters file, take the URL, copy it onto the clipboard, paste it here. I'll just save all of this. Let me copy this. Let's go back onto our custom deployment. So I'll edit the template, delete this, paste in my new template code, click on save, choose my resource group, go on to view and create. Now the validation has passed, and we go ahead and hit on create. Again, it will do the deployment of your resources, but here the main difference is that we have our SQL database, that definition, in a separate template, and we have the deployment of our Azure Web App in a separate template, and just linking them together. Let's come back once this is complete. And after some time, you can see the deployment is complete. Again, if you go onto your template GRP resource group, you can see the 3 resources in place, and then shortly you'll also see your Azure SQL database also in place. So in this chapter, we have seen how we could work with link templates. Now, in the prior chapters, we had looked at ARM templates that can be used to deploy an Azure Web App and an Azure SQL database. We had done that to our template GRP resource group. Just hitting on refresh, I'm going to delete my resources except for this template store in which we have our template files in place. Let me go ahead and just delete these resources. Now, let's incorporate these ARM templates within our release pipeline. So in my release pipeline earlier on, we always had our resources in place. This time, let's make use of our ARM templates within our release pipeline. The release pipeline I'm going to be using is a SQL app pipeline. This is used to deploy a web application onto an Azure Web App, and also make changes by adding a table and data within a database. If I click on edit just to refresh our memory, we had one stage, one job. We had 3 tasks. The first task was, if you remember, to create, it was an inline script, to create a table, a products table, and insert data into the table. The next task was to pick up our web application and deploy it onto an Azure Web App. And then we had some configuration settings. If I scroll down, we had the connection strings. I now want to add the deployment of our ARM templates within this pipeline. And again, just for recollection's sake, the build pipeline is also the same, which actually triggers this release pipeline. Nothing different here. It is taking the build of our project and then publishing it as an artifact, which will then be given onto our release pipeline. There's no change we're making here. The main thing is within our release pipeline. So what I'll do first is I'm going to go onto my storage account, onto the containers, onto templates, and let me also upload my main.json file. So I can have now all of my templates situated here itself. Let me upload my main.json file. Let me ensure that it is saved. Yes. Go back here. Let's upload the main.json file. Okay, we have this in place. Now let me go onto my pipeline. Let me add a new task. I'll search for ARM. There is a task of ARM template deployment. I'll click on add. Let me make sure it's the first task. Let's go and configure this task. Here I'll choose my subscription. Scroll down. The action is to create or update a resource group. I'll choose template GRP. It's asking for the location of my script file. Here in the location, I'll choose North Europe. Now we have the template. The template could either be an artifact that could be published onto the pipeline, or it could be a URL of a file. So for now, I'll choose the URL of a file in terms of the entire template link. So I'll go onto my templates. I can go here as well, onto main.json. Let me copy the URL of the main.json file, and let's place it here. So this is now going to first call our main.json file, and our main.json file is anyway going to call our SQL database.json file. The deployment mode is incremental. I'm leaving everything as it is. What are the changes I'm going to be making, which I normally do? So I said if I go on templates, I'll just go onto my SQL database, go onto edit, and make the change here. When it comes onto the server name, let me also copy server name quickly here. So I'll go down, change it here, go down, change it here. I said for you it might work, but for me, I'm just trying to keep it safe. Let me click on save. I'll go onto my pipeline. When I go onto my table creation, I need to change the server name. Otherwise, it's going to fail because our ARM template is deploying an Azure SQL server with a particular name. And don't worry, I'm going to show you a way in which you can actually pass the name from the ARM template deployment onto the subsequent task. Because obviously, you don't want to kind of change or hardcode the values within your task. Well, there is a facility where you can actually pass down the values in your task. But now I first want to show the basic thing of how do you incorporate the deployment of your resources via an ARM template. Scroll down, and do I need to change anything else? So this is fine. Yeah, also, let me go onto the firewall. I'm going to choose an IP address. See, when you deploy an Azure SQL database, I told that please allow Azure services by default. So when you create the SQL database in the wizard, you have the facility of saying that please allow Azure services to access this database. It's like having a firewall rule in place. But we want to ensure the same thing is also done here via the use of the pipeline. For this, I'm going to put the start IP address as 0.0.0.0 and the same for the end IP address. I'll uncheck this. Let me click on save. Let me go onto my Azure web app. I need to change here. If I go onto my templates, onto my main.json file, onto edit. So what is the web app name we are creating? I'll copy this and let me place it here. I'll just click on save again. I'll go onto the app server settings. I need to change the app service name here. I'll just write template GRP, that's my resource group. And I'll scroll down. I'll just quickly go on to my templates again, onto SQL database, onto edit. Just take the name of my server, scroll down. Remember, we have to also change it here in the connection strings. So you have to know where are all the references when it comes onto your database. Once this also is in place, let me go ahead and click on save. So we have everything now part of our pipeline. The first task is now going to create our resources, because in another tab, if I go onto my template grp.resource group, right, I don't have those resources in place. The only thing that I do have is the storage account. I'm going to now just directly create a release so that we can see this pipeline in action. Let me hit on create. The release is now in place. Let's come back once the release is complete. And after some time, when I come back, I can see the deployment is complete. If I go onto my template grp resource group, if I hit on refresh, I can see my resources in place. If I go onto the app service, if I take my URL, if I take the URL of the Azure web app and I go onto a new tab, I can see it is fetching data from my Azure SQL database. So the same web application which is picking up data from our Azure SQL database, the same pipeline we had seen before. The only difference now is we have all of the deployment of our resources done via the use of an ARM template. We don't have to create the resources beforehand. Right, so this marks the end of this chapter, wherein we have looked at how we can use an ARM template in our pipeline for the deployment of our resources. Now, in the prior chapter, we had seen how we could incorporate the use of ARM templates within our pipeline. Now, let's say that the pipeline runs again. We make a change onto our repository. If I go onto my repos, this is actually my SQL secure repository. I can go on to my pages and let me make a change onto the index page. I'll click on edit. See, currently it is version 1. Let me just quickly press version 2 and hit on commit. So let's say application version 2, hit on commit. This should obviously first trigger. So if I go onto my pipeline here, a build pipeline, the SQL app secure. And shortly enough, it should go ahead and trigger a release of my SQL app pipeline. So currently it's release number 9. So let's wait till this is complete. Let's see what happens. I mean, now in our pipeline, we have the ARM template deployment task in place, and then we have our subsequent task. Now, normally what should happen is when it comes onto the ARM template, it should already see that those resources are in place. It will not go ahead and deploy those resources again. So that task should be pretty fast, and then it will go ahead with the remaining task as normal. So let's come back once this is complete. Now I've come back after some time. Now my build pipeline ran perfectly well. When it came onto my release pipeline, actually my release 10 actually failed, and I'm not sure the reason why. If I go on the logs, it's saying that the server was not available, but the server is actually part of our template grp resource group. And when I reran the pipeline, so I got a new release 11, and that time it worked out fine. And if I refresh this page, I should be seeing version 2 of my application. Right, so that is in place. So not sure why the pipeline failed the first time around and came onto the server name, even though it is already present. But I want to show you what happens when you actually run your pipeline again. Hi, and welcome back. Now in this chapter, I just want to showcase one way in which you can delete your resources as part of your pipeline. So currently as part of our release pipeline, we have tasks in place, wherein first the deployment of our resources is going as part of our deployed test environment stage, and then we have the other tasks in place. Let's say you're going to have another stage here, which is deployment to, let's say, your staging environment. And this, you want to recreate resources in, let's say, a staging GRP resource group, or probably somewhere else in another subscription. You first want to go ahead and delete the resources that have been deployed as part of this particular stage. So let's say everything is in place, it has been deployed, testing has now been conducted, and after 2 days, testing is complete. They now want to move on to the next stage and deploy probably the same type of resources onto a staging environment. But they want to ensure that they delete the resources that were created as part of this particular stage. Let's show you one way in which you can go ahead and accomplish this. Now here, I have a script file that we can go ahead and use for the deletion of the resources. I'm using simple Azure CLI commands. The command I'm using is az resource delete. I'm giving what is the name of my resource group, what is the name of the resource itself. So I have 4 commands. The first one is for deleting my SQL database. The other one is for the SQL server. This for the web app, and the other is for the app service plan. I have to give what is the resource type. Again, if you want to get the resource type, I told you how you can actually go about doing this. Go on to the resource itself. So for example, I'm on SQL server here. The SQL server should be having properties. If you go onto it, if you scroll down in the resource ID, you can actually copy the resource ID onto the clipboard in Notepad, copied, and you'll be having your resource type here itself. So you can go ahead and take the resource type for your individual resources. I just need to change what is the server name that I have mentioned. That's a SQL server name. I'll copy this and let's place it here. Right, so that should be fine. If you go on to your pipeline, here, let's say we create another stage. So I'll go on to editing my pipeline. So in the pipeline, let me add a new stage. This is after deploy to test environment. I'll just put an empty job. I'll say deploy to staging. Let me click on save, click on OK. So here I'm saying that once the deployment onto the test environment is complete, then start the deployment onto the staging environment. You can also probably have another stage, maybe a cleanup stage, and then have the other stage of deploy to staging. We can add a task here. in the agent job, I can add an Azure CLI task. I'll click on add. I'll go to it. I'll put the name as cleanup test environment. I'll choose my connection. Here, let's make sure the script type is PowerShell. I'll do an inline script and let me paste everything here. Let me click on save. And then you can add other tasks for the deployment of your application onto your staging environment. If I go back onto my pipeline, you can have now a post-deployment condition wherein you have an approval in place. So let me put an approval. What we're trying to say here is, let me click on save. Close this. So I'm saying that once deployment is complete and all testing is conducted, an approval should be sorted before going on to the next stage, because in this particular stage, the first task is to delete all of the resources that were deployed as part of the prior stage. Let me go ahead and quickly just create a release. And let's come back once the release is complete within the deploy to test environment stage. Now, once the deployment onto the test environment is complete, so it's saying pending approval. So in another tab, I've logged in as TOC user 1. Go on to the releases. Here for deploy onto test environment. Let me put it as approved and click on approve here. This should now trigger the deployment onto our staging environment. Let's come back once this is complete. Now, once the deployment is complete, if I go onto my template GRP resource group, if I hit on refresh, so I have my storage account in place, I have my database also in place. But after some time, when you click on refresh, you should not be seeing that resource anymore. So now you've added another task which can go ahead and delete your resources once they are no longer required. Hi and welcome back. Now in this chapter, I just want to give a quick note. So I got this question prior on from students, when it comes on to deployment of the application onto multiple environments. So I told you in organizations, you could be having a separate test environment in place, a staging environment in place, and then a production environment. How can you make your web application point onto a particular environment? So by now, when you're looking at your task, you can see a lot of flexibility in the task itself. So currently in my deploy to staging, I have one task for deleting my resources, but then I can take my additional 4 tasks which involve the ARM template deployment, the deployment onto the Azure web app, the creation of the tables, and then the configuration string onto the staging environment, where I have different resources defined as part of my ARM template. And even in the template itself, you could go ahead and make the naming of your resources more dynamic in nature. You could probably put the names of your resources as parameters and then pass it in the parameters file. You can make that dynamic as well. And then in your pipeline, remember when you go onto your task, when you go on your table creation, here you can specify the SQL Server name. When you go onto the Azure web app, you can specify the web app name. And when you go onto app server settings, you can change the connection string accordingly. So now your application can actually probably point onto your staging database. You already have this flexibility within the task itself. It's up to you to ensure that you use that flexibility. I want to give this quick note to students because I used to get this question onto how do I make my application point onto different environments. Hi and welcome back. Now in this chapter, I want to showcase how we can basically have an artifact as part of the task when it comes onto our ARM template deployment. Earlier on, we had the template link, but in the template location, we can also have a linked artifact as well. For this first, what I'll do, I'm going to clone the existing repository that I have when it comes onto the repository linked onto the build pipeline and then subsequently linked onto this release pipeline. I'm going to have that main.json file, part of my code base, uploaded onto the repository. It will then come as part of our build pipeline, and from there, it will come onto our release pipeline. If I go onto my repositories, that particular pipeline is linked onto SQL App Secure. On my local machine in Visual Studio 2022, let me clone a repository. I'll browse for Azure DevOps. I'm choosing the SQL App Secure repository that I have and just a local temporary path on my C drive. I'll hit on the clone button. Here in Visual Studio, in the Solution Explorer, let me double click on the solution file so that I get a solution view now of my entire project. Within my project now, I'll right click and add a new folder. I'll name this as templates. Within templates, I'll add an existing item. I'll go onto my template folder, onto link templates, and choose my main.json file. I'm now having this main.json file as part of my application code. Again, this references our link template when it comes onto our SQL database.json file and our SQL database parameters. When it comes onto my template GRP resource group, so currently I don't have any resources in place. As I normally do, let me go onto the storage account. We go onto my containers, go onto templates, go on to SQL database, click on edit, and again, just make a small change when it comes onto the SQL Server name. Make the change here as well. Let me click on save. So this is one thing that's done. Obviously, I need to now commit this onto my repository. Before I do that, let me go onto my SQL app pipeline before I forget. Onto the table creation here, let me make a change onto the SQL Server because that is a change that we have made here in terms of the server name. If I scroll down, everything is fine. In terms of the app server settings, I'll make a change here as well. Let me click on save. Before I change, obviously, the ARM template deployment, let me go on to my pipelines and go on to the build pipeline. For SQL App Secure, I'll click on edit. The change I'm going to make here, when it comes onto my build pipeline, I'm going to have one more task when it comes on to publishing my pipeline artifact. So I have one pipeline artifact that's published that's basically for my build, for taking my build of my web application and passing it onto my release pipeline. I'm adding another task to create another artifact that is going to be published again onto my release pipeline. This time I'm making a reference onto my sources directory and I'm saying, please only take the files from the templates folder. See here within SQL app, I create a templates folder. Now only what is basically part of this templates folder, only pass that has an artifact onto the release pipeline. In the price section, I told you that I'll show you a way when it comes on taking selected files and passing it onto the release pipeline. You can do this by changing the target path. What is it that you want to take from this build pipeline and make it available onto the release pipeline? So only the files within the templates folder. Let me go ahead and click on save. So I'll say added publish task for templates folder. I'll click on save. This should actually start a build, but I'm going to cancel this build. Okay, this is fine. This should be cancelled for now because what I want to do is I want to go and make a commit basically of my file in my templates folder, otherwise it won't work. Go on to get changes. So I'll say uploading main.json. Let me do a commit all and a push. This might ask me to do a pull first. So it has pushed the changes and it should have triggered another build. Yes, that is done. If I go on to my repos, here within SQL app, I should be having now my templates folder in place and I have my main.json file also in place. I'm going to wait for actually this to complete. So let me go on to my pipelines. And quickly, once this is complete, before I actually, reach a release, so it'll definitely trigger a release. When a release is triggered, I'm going to go ahead and basically cancel that release because I want to make a change onto our release pipeline. So as soon as the build is complete, I'm going to keep a track of this. As soon as the job is complete, it's going to trigger a release and then I'll cancel it. So I've come back. I can see the build is complete. If I go on to my releases, it start a release. Let me go on to release quickly. And here, let me cancel the deployment on test. So it's canceling this particular stage. Right, so it's going on has failed. So again, the reason I did this is I want to now make a change onto my pipeline. I'll go on to the task when it comes on to the ARM template deployment. Here, in terms of the template location, I'm now going to choose a linked artifact. I can browse now. If I go on to my linked artifacts, I have my template artifact and I can choose my main.json file. It is now available because we had a build pipeline that actually released the artifact onto our release pipeline. Now let me click on save and hit on OK. Now let me just create a release. Let me go on to release and let's come back once this is complete. So I've just come back. I can see that when it comes on to my release, there was an error when it came on to deployment onto the test environment. Here in the ARM template deployment, it's saying a website with a given name already exists. If I go on to my web apps, I actually don't have any app services in place. Even if I go on to the template GRP resource group, I've refreshed it a lot of times and I don't see the resources in place. So this comes on to the fact why I frequently go ahead and change the names of my Azure SQL database servers. Because sometimes, even though the previous resource has been deleted, when it comes on to creating the resource again with a similar name, it just seems to have an issue. So I said it's not there here, but in the error, it's saying the website with a given name already exists. So as a workaround, that's why I normally change the names of my resources. Currently, I've only been doing it for my Azure SQL database server resources, but this time around, let me go ahead and do it for all of my resources. I'll again just delete the resources that I have here. Let me go on to SQL database.json. So unfortunately, I need to make a change here again. I'll scroll down, make the change here, click on save. One good thing about having everything in a central location is you can make the changes and then save it accordingly. I'll need to go on to my pipeline. I have to click on edit here, onto the tasks. Make sure I change the names here as well. So I know that this can be a painstaking exercise, but nevertheless, we have to ensure that we make these changes accordingly. Now I'll do for the web app, I'll put a different name here. For the app settings, okay, put template GRP. Let me scroll down, change the SQL server name. Right. Let me save all of this. And then let me go on to my repos here. I'll go and make a change onto main.json. So we have the plan here. Let me click on edit. I'll make a change. The same name I need to give here when it comes on to the name of my Azure web app. Right. Everything else seems to be fine. Let me go ahead and do a commit. I'll just do a simple commit for now. This should trigger my build pipeline and then trigger a release again. Let's come back and see whether the release actually goes on to success. So now I've come back. The deployment is complete. So in this chapter, I just want to show you how to use a linked artifact. If I click on refresh for my resources, I should be having my resources in place. But the entire idea of this chapter was just to show you how you can actually pick up your JSON file. Basically, your ARM template has a linked artifact. Just a quick note before I sign off. If you go on to the next stage of your pipeline, which is the deletion of the resources which I have, it might fail or it will fail. Because remember, you have to change the name of the resources that you are deleting in the subsequent stage. Just a quick note. Hi and welcome back. Now, in the prior chapter, we have looked at the use of release pipelines when it comes on to the deployment of our resources, our Azure web app and our Azure SQL database. Now, I want to go ahead and show you an example on how you can actually dynamically generate the name of your resources. First of all, as part of my template GRP resource group, let me go ahead and delete the resources again, except for my Azure storage account. Let me delete these resources. So more often than not, we might want to dynamically have the names of the resources in place. And then we want to ensure that we take those names and then put as part of our pipeline. See, currently when it comes onto our pipeline, let me edit our existing SQL pipeline. when it comes on to our task, if you go on to the Azure SQL table creation, here we are basically like hard coding the name of the Azure SQL server. But let's say we want to make this more dynamic in nature. We first of all want to dynamically generate the name of the SQL server, and then we want to ensure that that same name is carried forward in our release pipeline. So I want to show you an example on how we can achieve this. So I did a lot of research and a lot of homework, and it also took a lot of time to understand end-to-end on how we can accomplish this. So let's go ahead and see how we can accomplish this. The first thing is to make changes onto our resource manager templates accordingly. If I go onto, so I'll just save the script file and I'll close it. On the link templates, if I go onto SQL database, we're first going to make some changes here. So we have to make, first of all, changes onto our ARM template, because it's the ARM template that is going ahead and publishing our resources or deploying our resources as part of our Azure subscription. Here is where we first need to initiate the dynamic name creation for our resources. I'm going to do that for our SQL server name. Here under variables, I'm going to create a new variable. I'll put a name of SQL server name. And how are we going to define this variable? I'm going to use the concatenation function, or the concat function that's available as part of ARM templates. I'm going to concat the keyword of server. I'll then take or use the unique string function, again available as part of ARM templates, and just take a unique string from my resource group and dot its ID. So I'm just taking the ID of the resource group, that's template grp, taking a unique string from there, and then concatenating onto the server string. This is going to be our SQL server name. For the name here then, I'm going to change it onto, taking it from the variables now. In the variables, it is the SQL server name. Then if I scroll down for my database, I need to do the same thing. So I'll copy this variables, copy this and place it here. So taking the value from the variables for the SQL server name. And then if I scroll down, even when it comes on to the depends on condition, we have to take the variable here as well. The next thing I'm going to do is I'm going to go on to the output section. I now want to output the fully qualified domain name when it comes onto Azure SQL Server. This will then be taken by our main.json template, and we can take the outputs from there and pass it on to subsequent tasks in our pipeline. So outputs is a section if you want to output certain values or certain property values when it comes onto your Azure resources that you're creating as part of your ARM template. I want to get the fully qualified domain name, so just giving a name for the output here. This is of the type string, so I'll choose string. And what is the value? Here the value is actually a reference, so I'll choose reference. I need to go on to my variables, take the SQL server name, and I need to now take the fully qualified domain name. This is a property that will be available now for your SQL server resource that gets created. I'm going to save this, so everything seems to be fine. I'll copy all of this. So I'll go on to my SQL database.json file in my storage account. I'll place the new content here, and then let me click on save. Similarly, let me now go on to my main.json file. Let's make some similar type of changes here as well. I'm going to change just the name of my web app for now. So I'll create a new variable of web app name. Similar concept. I'll use the concat operator that's available. I'll concat the keyword of web app, and then again take the unique string. In the unique string, I'll take the resource group and its ID. And then if I scroll down, when it comes on to the name of my web app, instead of hard coding it, I'll take it from the variables. So I'll just copy the web app name, place it here. Then I'll ensure to copy this entire thing and put as part of the properties as well. And if I scroll down, right, this all seems to be fine. In terms of my outputs now, I'll have an output for the web app name. This is of the type of string. And the value is basically, again, my variables. It's just my web app name that I have here. So I'll just copy this, scroll down, let's place it here. I also want to take the output that's going to come in from my link template. So if I want to now take an output from the link template, I first need to find the output itself in the link template and then take it from our main template here. Again, the type is a string. And now how do I get its value? Again, it's a reference. In terms of the reference, we have to give what is the name of our link template. So if I scroll on top, the name I've given is link template, so I need to paste it here. We are referencing our link template. dot its outputs, and dot what is the name of the output we had given. So here, if I scroll down, the name we had given was SQL Server FQDN. Copy this, place it here, and then dot its value. Now I said here, we're just passing the output from the link template onto the main template. And these outputs which we get here are now very, very important. We're going to use these outputs as part of our pipeline. First thing, just to make sure everything works, let's just run our ARM templates as it is. Normally I go step by step and I'm going through an entire process, especially when it comes on to automating our pipelines. Step by step, first make sure everything works. I'll copy all this. We have our SQL database.json file in place as part of template GRP. Don't have any resources in place. Let me create a new resource. This is going to be a template deployment. Hit on create. Build my template. Let's place all of this. This is my main.json. Click on save. I have my template GRP resource group. Go on to view and create. The validation is passed. Let me go ahead and hit on create. Let's come back once this is complete. Once the deployment is complete, I'll go on to the resource group just to look at my resources. You can see the plan name is the same because we haven't changed that. If you look at our SQL Server name, you can see the keyword of server, and it has been appended by some unique string that has been taken from the ID of the resource group. Similar case when it comes on the Azure Web App as well. We have the web app keyword, and again we have the unique string when it comes on the ID of the resource group. So the first step was to ensure that we dynamically generate the name of the resources. Again, you can do it also for your app service plan. Since in our tasks we are only dependent upon the SQL Server name and the web app name, that's why I added dynamic features onto the names for these resources. If you go on to your template deployment, right? If you go back on the overview for the template deployment, if you go on to outputs, you can see the outputs here. You have the web app name and the SQL Server fully qualified domain name. This is what is important. It's these values now that need to be carried in our pipeline so that the task can work accordingly with these dynamically generated resources. Hence, the first thing, the most important thing when it comes on to building that pipeline is to ensure that you dynamically generate your resources when it comes to their names, and also ensure that as an output, you have them in place. So let's mark an end onto this chapter and move on to the next. Now, in the prior chapter, we're going ahead and ensure that for our ARM templates, we have outputs in place. Let me go on to the resource group and now delete the resources because we're going to recreate them again. Let me delete them. So the first step was just to ensure that the ARM templates works as desired. And now we can use that ARM template in our pipeline. So now let me go on to my SQL app pipeline. Let me go on to the ARM template deployment first. To make this a bit simpler, let me scroll down. Instead of a link artifact, let me make this a URL of the file so that we can just create the release. I'll go on to my main.json file, which is in my templates. Let me first copy the URL. move this here. Let's place it here. Let me click on save. At the same time, from Visual Studio Code, let me copy the code for main.json. And ensure that it is replaced here. Let me click on save. Now, going back onto our pipeline, I told you that there are two outputs that we had, right? If I go onto my main.json file, it's the web app name and the SQL Server fully qualified domain name. So with these outputs, we need to map it onto variables that can be defined as part of our pipeline. Remember that there are predefined variables. So when it comes onto your pipeline.workspace, or when it comes onto your build.sources directory, there are already predefined variables when it comes onto your pipelines. And we can define variables here, extra variables, which we might want as part of the pipeline itself. So we have to now define those outputs as variables here. I'm going to click on add. For the name, let me take the web app name, place it here. Scroll on to the right. I'll say it is settable at release time. Let me add the other variable. Click on add. So initially, we don't need any values. If you want, you can provide some dummy values. We're actually going to populate these values via the use of a PowerShell script. For now, I'll just mark the settable at release time. So the first step is to define two variables here. This is a very important step. I'd actually done the PowerShell script and I'd done the task, and I still wasn't able to simulate the passing of values from one task to the other. And the entire time I was actually banging my head and trying to figure out what exactly is wrong. And the thing that you have to do is you have to define those variables here as well as part of your pipeline. And then you can set it as part of your task. So first thing is define your variables. Click on save. Okay, let's go back onto our task. For the ARM template deployment, which is now going on to the main .json, it is now giving some outputs, right? The two outputs. Now these outputs are going to be given as a complete JSON to this pipeline. We have to give a name. You can give any name here. This is going to be the name of the entire output. So all of this output is going to come as JSON, and this entire content is going to be passed on as an output after this ARM deployment task. It is now your responsibility to take this output. Within this output, I said you're going to have the outputs for the web app name and the SQL Server name. It's now up to you to go ahead and extract those contents and set the variables accordingly. For this, we're going to be making use of a PowerShell script file. This PowerShell script file is actually going to take that value of the resources deployed, and I'll show you how we can pass that value onto the script. It's going to convert it from JSON into this particular outputs variable, and then I'm going to extract the web app name, its value, and the SQL Server FQDN, its value. I'm just writing the values as a debug option so that we can see it in the logs. With the help of write host and task.set variable, we can now set those variable names onto the values. So I told you from that output JSON, which we are getting from the ARM template deployment, I'm first extracting the web app name and the SQL Server fully qualified domain name, and then I'm setting these variables in the pipeline that we had defined earlier on. This script is going to be part of our code, right? If I go on to Solution Explorer, this is the code we have been using earlier on as part of SQL app. When linking an artifact, we have the main.json as part of templates. Now in templates, just to make this very simple, I'm going to add that script file. So I'll click on add. Add an existing item. I have that script file. I'm going to add it here. Once this is added, let me commit this onto the repository. How do I commit all and push? Do a pull and a push. So this should now trigger a build within Azure pipeline. So that's going on. Now this would also trigger a release of the pipeline. So first of all, let me click on save to what we've done for now. For my previous release which I have, I'll just go on to the release. Here, let me just hit on cancel. Go back here. So I'm just waiting for this build to complete this job. So what it's doing is remember, as part of this build, if I go on to edit, at the end we had added a step to publish the pipeline artifact. This was all of the files in the templates folder. That's why I had placed this script file in the templates folder. Now even the script file is going to be passed on to a release pipeline. But before the release pipeline actually starts, I'm going to cancel it. I just want the build to complete because we still need to complete the editing or configuration of our release pipeline. So let's just wait. So the build pipeline is complete. It's gone on to the release. Let me hit on cancel to cancel this release. Let's go back on to editing our pipeline. I'll again go on to the task. So where we had left off, we had added the deployments output when it comes onto a name. So I said the outputs are going to be given as part of this name. I'm going to add now another task. This is going to be a PowerShell task. So I'll choose PowerShell, click on add. I'll go on to the script here. In terms of the file path, I'm going to browse now. So as part of the template artifact, I should now see my script file in place. I'll hit on OK. Remember, as part of the script file, we had this ARM values. Now here in the arguments, we want to pass something onto ARM values, which will be passed on to our script. And can you guess what we need to pass in? We need to pass in the resources deployed type of variable, which we had defined in the ARM template deployment. Let me just click on save quickly. So basically what we're doing is we are now taking the output which is available here, passing it on to our PowerShell script. And in the PowerShell script, we have ARM values. We are taking all of this now, passing it in ARM values. And if I go on to the script, ARM values is going to take in the web app name and the SQL Server fully qualified domain name. Now, again, as an example, I'm using PowerShell here. You could also create another script in probably Bash or something to kind of extract the names. As an example, I'm just showing you how we could extract the names, the outputs using a PowerShell script file. Right. So I told you that these two statements now are going to set the variable names that we have defined here. Currently, these are blank. These are now going to be set by the use of that PowerShell script. If you want to confirm that those values are indeed being set, we can add another task. I'll add a bash task. I'll click on add. This can be after the PowerShell script. This can be an inline script. I'll just put an echo of the server name is. I'll take this, copy it here, and we have the web app name. And the web app name is this. This is just to confirm. Actually, you can't kind of echo back the values for the SQL Server, basically the outputs in the same PowerShell script. Task. So I will also try to do this, in my PowerShell script. Right, so I could write the values which I extracted from here, but after setting the variables just to make sure that the pipeline variables have the required values, because I said I took a long time in trying to get all of this to work, and every time when I was trying to, let's say, write host, the name of the variable here itself. In the PowerShell script file, it would come as blank. And I couldn't understand why it's coming as blank, because I was getting the values correctly here, but then the variables were still coming as blank, even though I'm setting the variable values here. And then after going through our forums, I saw that within the script in which you're setting the variables,